Okay, in the last video, we derived the first Pythagorean trig identity. And what we just did, just to recap quickly, is we looked at the unit circle and the point on the unit circle with a angle theta. And we realized that x and y on a unit circle are cosine theta and sine theta. So you basically just plug cosine theta and sine theta into the unit circle equation right here, and you come up with the first Pythagorean trig identity. Well, the other two Pythagorean trig identities are based on the first Pythagorean trig identity. So if you can remember the first one, you can remember the other two. It's actually very simple to derive. The first thing you do to derive the second Pythagorean trig identity, I'm just going to write a number 2 here so we know what we're doing. Okay, I'm going to write the first one down because we're going to doctor this first equation and turn it into the second one. Plus sine squared theta equals 1. Well, what do we have to do to get the second one? Let's see what happens when we divide everything by cosine theta squared. Just every term in this equation by cosine theta squared. Cosine theta squared. Okay, well now what happens, by the rule, I'm going to write it up here. I'm sure everyone's aware of it, but let's do it anyway because it can't hurt. And by the power rule, that a fraction to a power is the same as the numerator to that power over the denominator to that power. And that is very important, especially when it comes to the Pythagorean trig identities, because we're kind of banking on that. Okay, so the second thing that we're going to, oh, that is not the right color. Okay, the second thing that we're going to do here is we're going to take that square out to make clear what's happening. You can do it in your head, but in this particular case, we're not going to do that. What you end up with is cosine theta over cosine theta squared plus sine theta over cosine theta squared over cosine theta squared. Excuse my desktop notification sounds. Okay, equals 1 over cosine theta squared. Okay, so what this is going to simplify to is 1 squared, which is just 1, plus tan squared theta, because sine over cosine is tan, equals secant squared theta, because 1 over cosine is secant, because they're reciprocals of each other. Okay, so that's our second Pythagorean trig identity right there. That was not so hard, was it? Let me just write it down. Let me just write it down in our box up here. 1 plus tan theta squared equals secant theta squared. Okay, so now we just have the third one left to derive. And we can do that with a pink color. Now we just have a third one left to derive, and I'm going to go up here, and now we're going to go back to our original Pythagorean trig ID, because they're not based on each other stacked, they're just both based on the first one. So we're going to go back to cosine theta squared plus sine theta squared equals 1. Well, what do we have to do to this to get the third one? Well, what if we divided everything by sine theta? If we divide everything by sine theta, we can derive the third Pythagorean trig identity. So we divide everything by sine theta squared, sine theta squared, and sine theta squared. So now we're going to end up with cosine theta over sine theta, which is going to be cotangent theta, just forewarning you, squared, plus sine theta over sine theta, which is going to be 1, squared, which is still going to be 1, equals 1 over sine theta squared, which is going to be cosecant squared, because sine and cosecant are reciprocals of each other. So in the end, we're going to come up with cotangent theta squared plus 1 squared, which is just 1, plus 1, equals cosecant theta squared. And that's our third Pythagorean trig identity. So basically, if you can just remember the first one, you can remember them all. And the first one is really easy to remember because you just think unit circle equation, xy, plug it in. That's all you have to do. So I'm just going to write this down. This is going to be cotangent theta squared plus 1 equals cosecant theta squared. And there you have all three of the Pythagorean trig identities.